All right, so what we're going to talk about today, this is section 6.1. We're going to move into solving inequalities. And the cool thing about inequalities is that you already pretty much know how they work. We just get to use them mathematically and understand a few concepts. So the first idea here, I'm going to show you a picture, all right? And this picture has to do with some bumper cars. All right, here is the bumper car picture. I'm going to move it up, and I'm going to make it a little bit bigger for everybody. And I just want you to answer these questions by yourself and jot down what you think the answer is. All right, has everyone had a chance to sort of look at the picture and jot down some questions or jot down the answers to these questions I have here? You guys ready to talk about it? Yeah. Okay, good. So here's what we're going to do. We're going to call on a few people here. All right. Cecilia, you come up first. So, Cecilia, the question says, who cannot ride? How can you describe who cannot ride in this particular case right here? Cecilia. Wait, could you say one a little bit louder? Yeah, whoever's shorter than 42. So we could say people shorter than 42. If you're shorter than 42 what? 42 inches, yeah. If you're shorter than 42 inches, okay? Does that make sense? Did anyone put anything different? What'd you put?
X is less than 42.
He said X is less than 42. What does the X represent? The height of what? The person. So he said, he wrote, and similarly, he said this. X is less than 42? Yep. Does that sound good to you guys? Did anyone else do X is less than 42? Yeah? One other person? All right, good. Okay, who can only ride? Who can only ride? And let's talk to Damien. Who can only ride? Yeah. 42 and up. 42 to 48. So people who are bigger than 42 inches, right? So 42 all the way up to 48 inches. Oh, 47 actually. Okay. 47.9. Just okay. So he says 42 to 47. Do we agree with that? Who says yes? Put your hands up if you agree. Okay. Who can only ride? Who can only ride? They can ride, but they can't drive. Who agrees? Is he right? I'll let the record show many people are agreeing, but some people over here are not agreeing. Do you guys agree? Yeah, okay. He says, 40. Did anyone do anything different? Yes, what'd you do? Yes, your hand was up?
No,
oh, okay. What'd you do, Tyler?
47 is greater than or equal to X, and X is less than or equal to 42.
And X is less than or equal to 42. But all in one equation. You just wrote down. But are those saying essentially the same thing right there? What we just said? You have to be 42 to 47 inches? Yeah? Okay. Who can do both then? Let's talk to Kyle. Your name came up. Who could do both? People 42 and above? Look at that. Is that what the picture says? Who can do both? Who can drive and ride? So people who are taller than 48 inches, right? Taller than 48 inches. Do you agree with that? Yeah. If you're 48 inches or taller, you can drive and you can ride. Does that sound good to you guys? Okay, so if I'm 47 inches tall, what can I do? Can I do both? Nope, I can only ride, right? I can only ride. All right? This is a great example of why we need to understand inequalities. And inequalities appear all over the place. Here's our next little example here. Let's talk about a driver's license. Okay? Now a driver's license. In the state of California, in order to get your driver's license, not your driver's permit, but your actual driver's license, how old do you have to be?
16.
You need to be 16. That's the law. At 15 and a half, you can get a permit, but to get a license, right? We must be older. We must be 16 or older. Is that true? We have to be 16 or older. So, if I was going to write an inequality on the number line, okay, here's the number line right here. And if I put 0 right here, someone who is 0, right? That's kind of silly, right? Someone who's 1, somebody who's 2, so all the way up to somebody who is 16, all right? if this is a number line, how would I represent the people who are able to drive on the number line? What would I do? Yeah, Rita. Make a circle where? Over the 16? Okay, here's a circle over the 16. Then what? Fill it in. Now, why would you fill it in? Because you can be 16. Yeah, I agree. And you make an arrow going to the right. Now, why do I want arrows that go to the right? How come? Because you have to be older. Is that everyone cool with that part? You have to be older than 16. All right, so this is a basic understanding of sort of inequalities. All right, now we're going to get into some properties. We're going to talk about the addition property of inequalities. And there are basically 4 of them here, but they all kind of go together. All right, and we're gonna explore this idea here for the first one. We're gonna explore something. So, does everyone in this room agree that 2 is bigger than 1? Everyone here in the room agree that 2 is bigger than 1? Yeah, you guys agree with that? Okay, now here's what I'm gonna do. All right, I want someone else to pick any number out there, any whole number out there. Pick a whole number. 7. Good. Okay, that's 7. Okay, now, is it still true if I take 2 plus 7, will that still be greater than 1 plus 7? Is that the same thing? So, do you notice that all I did, what did I do? I added 7 to both sides. Am I allowed to do that? Does that change anything about the statement that I made before? Let's see here. 2 is bigger than 1. Okay, that works out. And then 2 plus 7, that's 9, right? And 9 is definitely bigger than 1 plus 7, which is 8. So that still holds true. You guys are cool with that part? That's basically what the first rule is saying. All right? And here's how it says it. It says it a little bit differently. It says this. If you know that A is greater than B, then you know that A plus C will be greater than B plus C. Now that looks a little bit different, doesn't it? It is, but it's essentially the same thing we just said out, right? If 2 is bigger than 1, then 2 plus 7 will be bigger than 1 plus 7. It's the exact same argument. Doesn't that make sense? You guys follow along? Okay, good. Let's put the rest of these up here, okay? Now, if A is greater than or equal to B, then take a guess what's going to happen. A plus C will be what? Greater than or equal to B plus C. You agree with that? So what's the only difference here between these two statements? One's greater than, and one's greater than or equal to. Greater than or equal to. Okay, you can imagine how the last two go. If A is less than B, then what are we going to say? A plus C is less than B plus C. And lastly, right, if A is less than or equal to B, then we know A plus C is less than or equal to B plus C. So this right here, these are 2.5. All right, here we go. We're going to do an example that illustrates the addition properties of inequalities. We have n minus 3.5 is less than 2.5. And we're supposed to solve and graph these inequality system. Okay, which one's the variable? What's the letter that represents the variable? N. And then what does this statement say? It says n minus 3.5 is less than 2.5. Okay, if I want to solve for n, I'm going to treat this the exact same way I would treat an equation. What do I need to do to get n by itself? Add what? Yeah, we're going to add 3.5 here. And we're going to add 3.5 here. So this is essentially what we're saying. We're saying n minus 3.5 plus 3.5 is less than 2.5 plus 3.5. Now, how come we can jump from this statement to that statement? Which property up here allows us to do that? 1, 2, 3, or 4? 3. Very good. Property number 3 allows us to do that, right? If A is less than B, then if I add something to both sides, I know that A plus C has to be less than B plus C. So now I know that n must be less than, how much is 2.5 plus 3.5? 6, isn't it? Okay, great. N is less than 6.
And then I graph it.
And then we have to graph it. Now, here's the cool thing about graphing inequalities, the way that I need them done. It's very, very simple. I only need 2 points on the graph. I only need 2 points on the graph. I need 0. Show me where 0 is. Okay? So if that's 0, where does the 6 have to be? To the right or to the left of 0? It needs to be to the right. So I'm going to call that 6. Notice, I do not need to put every little tiny little mark in between 0 and 6. I just need 2 points, the 0 and the 6. Does that sound good to you? Okay, now, how do I apply the statement n is less than 6? Yeah, what do I do, Josh? A hollow circle, yes. And it's pointing to the left because I want all numbers that are smaller than 6. And if you want to take a test point, you can test 0 and plug 0 in. So see, is 0 less than 6? Is that true? Yes, that is true. But if I take a point that's to the right of 6, let's say 9, if I plug that in, is 9 less than 6? Is that true or false?
No.
That's false, so I do not want to shade that way. Okay, so we spoke about the addition properties of inequalities. Now we're talking about the subtraction properties of inequalities. And we're going to start off by saying this. Do we all agree that 3 is less than 5? Put your hand up if you agree. 3 is less than 5. Okay, everybody in the room, their hands are up. Good. Yes, 3 is less than 5. All right, now I'm going to subtract 1 from each side. Watch this. I'm going to say 3 minus 1. And the question is that less than, greater than, or equal to 5 minus 1. So notice that all I've done was I've subtracted 1 from each side. How does that affect the inequality sign? What do you guys think? It doesn't. Yeah. It still says that 2 is still less than 4. We agree with that? All right, good. This is the sort of the basis, sort of the setup for the inequalities of subtraction. And there's 4 of them, just like there were before. 1, 2, 3, and 4. So you can imagine how the first one's going to come out. We're going to say, all right, if we know that A is less than B, then we know that A minus C is less than B minus C. If A is less than or equal to B, can we say the same thing? Yeah, we sure can, right? Then A minus C less than or equal to B minus C. What happens if it's greater than, though? What happens if it's A is greater than B? Can we say the same thing? A minus C is still bigger than B minus C. Yeah, because we're subtracting the same thing from each side, right? As long as you don't change the value of the C, we're good. So, if A is greater than or equal to B, then same thing, right? A minus C is still greater than or equal to B minus C. And those are our subtraction properties of inequality. And are those kind of like intuitive? You guys feel pretty comfortable with that? It's pretty intuitive, right? All right, let's solve and graph. Last example here. We're going to solve and graph. And the inequality that we're going to take a look at is this. 3 is less than or equal to y plus 8. 3 is less than or equal to y plus 8. All right. If I want to isolate for y, if I want to solve this and isolate for y, and I treated that inequality sign as an equal sign, what would be the proper process to get that y by itself? We would subtract 8. Why would you say you subtract 8? Because it's the inverse of adding 8. Nice. So how much is 3 take away y? 3 take away 8. Negative 5, yeah? Negative 5 is less than or equal to y. Now, because we subtracted the same number from each side, right, then we know that step number 2, or property number 2, says it's going the inequality sign is going to stay the same. Now I need to graph it. And you have to be very careful about this particular statement. What's that? Negative 8? Yeah, okay. Now, before we graph this, okay, I want to ask you a question. Is 3 less than 5? Is that a true statement? True or false? Everybody. True. 3 is less than 5, right? Is 5 greater than 3? True or false? True. Right? Now here's the tricky situation. Both of these statements are true, and a lot of students get hung up on the direction of the inequality sign and how to graph it. So here's what I would suggest to you. Always, always, always put the variable, which is this thing, on the left-hand side. If you do that, then your number line will line up according to the same direction that the inequality is facing. So if negative 5 is less than or equal to y, what can I say about y then? Y must be what? Greater than or equal to negative 5. You guys agree with that? So these are both saying the same thing. And the reason they're saying the same thing is because for the same reason that those two are true over there. They're both saying the same thing. There's two different ways to say the same idea. So if I'm going to graph it, okay, I'm going to put 0 on my number line. What's the other point I need on my number line? Negative 5. Good. Here's negative 5. And how do I indicate all numbers that are bigger than or equal to negative 5? Yes?
Bold circle.
Yes, bold circle. Then what? And we go to the right. All right? And we shade in this way. So do you see how the direction of the arrow is the opposite direction in this case? Did you guys see the difference there? But it's the same direction in that case. That's why I recommend writing it this way. However, both are still